Hello, and welcome to the Redox Reactions screencast. I'm Mrs. Willie, and let's get started. So I'm going to introduce to you redox reactions. You have learned about the 5 types of chemical reactions: synthesis, decomposition, combustion, single and double replacement reactions. So in redox reactions, there is a direct transfer of electrons from one reactant to another. So all of those types of reactions that you've already learned about can now also be classified as redox or not redox. So water facilitates this electron movement and participates directly in the solution-based reactions. So example, rusting is an example of a redox reaction. So first you need to learn how to assign oxidation numbers. So oxidation numbers signal when the electrons have been transferred and indicate a redox reaction has occurred. So the rules. The rules are if there is an element that is uncombined, so it is monatomic or naturally diatomic, then it gets assigned an oxidation number of 0. For example, sodium, monatomic sodium would get an oxidation number of 0. Diatomic chlorine, if by itself, would get an oxidation number assigned of 0. Monatomic phosphorus, so in this case, you see there is a subscript of 4 there, but it is monatomic. It is not bound to any other element. It would get an oxidation number of 0 as well. The second rule, the oxidation number of a monatomic ion equals the charge on the ion. So if I see Cl minus 1 or O2 minus, or N3 minus or C4 plus in the equation, the chemical equation, then I would just assign that same charge as its oxidation number that I am seeing on the superscript. Rule number 3, the sum of the oxidation numbers in a compound or molecule is always equal to 0 because those are neutral. So our example here is carbon dioxide gas. The oxidation number of one carbon and the 2 oxygens added together is equal to 0 overall. So you would have to determine what the oxidation number is for the carbon by itself and the oxygens. There are 2 of them in that molecule. We'll do an example of that later on. The sum of the oxidation numbers in a polyatomic ion must equal the charge on the ion. So you've memorized some of these. An example would be the nitrate ion. The nitrate ion has a charge of -1. So the oxidation number of the 1 nitrogen and the 3 oxygens inside that nitrate ion must add up to -1. Ammonium is our other example, which has a +1 charge. So then 1 nitrogen and the 4 hydrogens must add up to a +1. The more electro element is assigned the number equal to its charge if it were an ion. So if I have nitrogen monoxide, then the O is more electronegative, and its oxidation number would be equal to its charge, which is -2. So that says there that the nitrogen would have to be a +2 to make that molecule have an overall charge of 0, which was rule number 3 above. Next rule, the oxidation number of fluorine in a polyatomic ion or a molecule is always -1 because it is the most electronegative element. Next rule, oxygen has an oxidation number of -2 unless it is a peroxide, which you have seen before because you memorized, where its oxidation number is a -1. So if I see calcium oxide, where the subscripts have been reduced, then I know that it is the oxide and not the peroxide. So I would assign the oxygen a -2. If I see CaO2, where the 2 subscript on the O has not been reduced, then I know that it is the peroxide, and the oxidation number of the O in that case would be a -1. Hydrogen has an oxidation state of +1, if it is a cation, and a -1 if it is an anion. Remember, if it is in the front, the H is a cation and would be assigned a +1. If it is in the back or to the right, it is an anion and would have an oxidation number of -1. Groups 1A and 2A elements have oxidation numbers equal to their charges, +1 or +2, and aluminum has an oxidation number equal to its charge of +3. So NaCl, Na would have an oxidation number of +1 because Na is found in group 1A. So let's practice assigning oxidation numbers. So we have to find all of the oxidation numbers in the carbonate ion. The way we do this is we have to look back at our rules. So we know that because this is an ion, they all have to equal -2. So all of them inside of all of the elements inside of our ion have to have a -2. So if we were in algebra, they would say that that equals -2. Then I look at the more electronegative atom in this. The more electronegative atom in this is oxygen, so it gets assigned a -2 because I know that this is not the peroxide because it has the 3 subscript on there. So then all I'm looking for is the carbon. So the carbon's oxidation number becomes X. I know there are 3 oxygens, so I'm going to multiply that -2 times 3, and then it's just algebra. So I'm going to distribute the 3 to the -2, so -2 equals X plus -6. Then I'm going to combine like terms, so I'm going to add the 6 to both sides. So then this becomes A plus 4 equals X. So in this case, carbon's oxidation number is going to be +4. So let's do another one. Find all the oxidation numbers in iron 2 cyanide. So this time they did not give me the formula, so I have to write the formula first. So iron has a symbol of Fe. Cyanide, because I memorized this from my polyatomic ions, is Cn-, and then the Roman numeral tells me that the charge on the iron is a +2. So then I can write this as FeCN2. So I now know the formula is FeCN2, and then because this is a neutral formula unit, I am going to make all of this equal to 0. So 0 equals, and then becomes a little tricky here because I know that the cyanide has to equal a -1 in this, so I know that there are 2 of those. And then I also know that the Fe was a +2 here, so then I can just figure out from there that I can do what's going on inside the cyanide. So if I know that iron had a +2, then I would put a +2. Then I'm going to add 2 times X, because I don't know what the carbon is, but I know that the nitrogen is the more electronegative element, so it is going to have its charge of -3, but there are 2 of them, so I'm going to take 2 times -3, and then just do some algebra. So let's distribute in our 2 to the -3, so I have 0 equals +2 plus 2x plus -6. Then I'm going to combine like terms. So I have 0 equals plus or minus 6 plus 2. So this becomes 2x minus 4. Then I want to get the x or isolate the x. So I'm going to add 4. So this becomes plus 4 equals 2x, divide by 2. So x equals a positive 2. Then that means that carbon equals a positive 2. So I know iron is plus 2, carbon is plus 2, nitrogen is minus 3. So let's practice assigning oxidation numbers again. Another example for you to do is ammonium dichromate. So again, they did not give me the formula, so I'm going to write NH4 plus, and dichromate is Cr2O7 with a 2 minus charge, Cr2O7 with a 2 minus charge. Then I'm going to write the formula for that. So this becomes NH4 parentheses 2 Cr2O7. And then we have to assign oxidation numbers to these. This is a crazy one. So we know again that all of this is going to be equal to 0. So let's look at this. So 0 equals, and then I know that NH4 has a plus 1 charge. So nitrogen is the more electronegative element there. So I'm going to take a 2 times minus 3 plus I have 2 times 4 times plus 1 plus Cr2O7. We're going to say that that is our X because we don't know what chromium is, but we know we have 2 of them, plus oxygen is the more electronegative element there, so I know that I have 7 times minus 2. So this is going to be quite a bit of algebra here. So let's see if we can distribute some of these parentheses and figure out where we can then combine like terms. So 0 equals 2 times negative 3, which becomes a minus 6, plus 2 times 4, which is 8, times plus 1 becomes plus 8, then plus a 2x, and then 7 times minus 2 becomes a minus 14. So now let's combine our like terms here. So 8 plus a negative 6 becomes a positive 2. So 0 equals positive 2 plus 2x minus 14. I still have some that I can combine here. So 0 equals 2x minus 12, but I'm going to add the 12 to isolate the x. So then this becomes positive 12 equals 2x, divide by the 2, plus 6 equals x. So chromium in this case must have a plus 6. Plus 6 equals Cr. So this becomes plus 6. This was a negative 2. This was a plus 1. This was a minus 3. All right. In some cases, the oxidation number of an element in a compound or an ion can be 0 or a fraction. It's okay. So let's do an example of what this looks like. So we're going to find all the oxidation numbers in magnetite. So I gave you the formula this time because no one is going to know how to develop that formula from the name magnetite. So again, a neutral formula unit. So we're going to start with 0 equals 3x because I have 3 of the irons, and I don't know what the oxidation number for the iron is, but I do know that this is an oxide and that O is the more electronegative element, so I'm going to do 4 times a minus 2. So 0 equals 3x minus 8. Then I'm going to add 8 to both sides. So 8 equals 3x, divide by 3. So in this case, our oxidation number for iron is equal to 8/3. So x equals 8/3, or iron equals 8/3, a fraction. So it is okay. Do not get freaked out when you have an oxidation number that is equal to 0, because we learned that's one of our rules. When there's a monatomic element, then it gets assigned 0. Or if you have a fraction, like in this case where iron's oxidation number is 8/3. All right, so now let's talk about where the name redox comes from. So redox comes from reduction and oxidation. So reduction is a complete or partial gain of electrons by a reactant. So in the example that I have given you, chlorine, the diatomic gas chlorine, adds 2 electrons to become the chloride ion in water. So you can see that it gained 2 electrons. So it gets tricky because reduction actually stands for the charge getting smaller. So I went from a 0 to a -1. So because that charge got smaller, it is a reduction half reaction. Then you have the other half of redox, or oxidation, which is the complete or partial loss of electrons by the reactant. So it's really easy when you have half reactions like these examples I just gave you, where I can see that the electron is a product. So my reactant lost an electron. And so I went from a 0 to a +1 charge. And so because it lost that electron, this is a oxidation half reaction. So we put them together in chemical equations. Most of the time you do not see half reactions, though you could see them in your practice problems or in a CFU or on a test. So I wanted to show you what a half reaction looked like. So those last 2 examples are half reactions, but they are in conjunction with one another, hence redox. So it gets a little more confusing when you have to do this as a whole chemical equation. So I had split those into half reactions, but the actual chemical equation would look like I took sodium plus chlorine gas to make sodium chloride. So the reduction half reaction is the chlorine gas because it went from a 0 to a -1. And then the oxidation half reaction is when the sodium went from a 0 to a +1. So the chlorine gains electrons while the sodium loses electrons. The charge of chlorine reduced to -1. The charge of sodium increased to +1. And then you can assign the oxidizing agent and the reducing agent. So just think about this as after I have figured out which side or which reactant is where the reduction is occurring, then it is the oxidizing agent or the opposite of the reduction. And then when I have determined what is the oxidized reactant, then it is the opposite of that. It would be the reducing agent. So let's do some examples of these. First, let me help you to remember some of this. So there are some acronyms that can be helpful in remembering how redox reactions work. So one of them is Leo the lion goes grr. So loss of electrons is oxidation, or gain of electrons is reduction. Another one is oil rig. Oxidation is loss. Reduction is gain, to help you remember which is the oxidation and which is the reduction. And then always the oxidized reactant is the reducing agent, and the reduced reactant is the oxidizing agent. So let's do some practice with this. So are they redox or are they not redox? So let's do this first by assigning oxidation numbers to our reactants. We know that copper is going to be 0, and then we know that silver is going to have a +1 here. We know that oxygen is a -2. So that makes the nitrogen in this case a +5. So now let's look at what happens on the product side. We know that any monatomic element is a 0, so silver is a 0 here. Copper is a +2 because the 2 that was out this subscript came from the copper, so I know that copper is +2. And again, that I know that oxygen is going to be a -2, and that makes our nitrogen a +5 again. So if I look at this, then I have to determine where the changes occurred. So I know that copper went from a 0 to a +2, and I know that silver went from a +1 to a 0. So remember your acronym. I use oil rig. So oxidation is the loss of electrons. So copper lost electrons because it went from a 0 to a plus charge. So this is where oxidation occurred. And then for silver, it had to have been a gain of electrons because it became more negative, or it went from a +1 to a 0. So this is reduction. So in A, yes, this is a redox reaction. So then I look at the second example here. Again, I have to assign oxidation numbers. So I know that in this case, oxygen is going to be a -2 because it's the most electronegative. Hydrogen is going to be a +1 because it is acting as a +1 there, because I know that hydroxide has a -1 charge. And then sodium is in group 1, so it is going to have a +1 charge. Hydrogen is at the front, so I know for a fact it is acting like a cation here, so it has a +1 charge. Oxygen is a -2 charge. And so then we have to look at figuring out sulfur. In that case, I know that sulfur has to be a +6, because sulfate has a -2 charge, and 4 times 2, -2 is -8, so that has to be a +6. And then on this product side, I know that hydrogen has to be a +1. Oxygen is the more electronegative atom, so -2. Sodium's group 1 stays a +1. Again, -2. And then sulfur, again, is going to have to be a +6. So if I look, sodium is a +1 on the reactant side. It is also a +1 on the product side. Oxygen remains a -2 in all of the reactants and the products. And hydrogen remains a +1 in all of the reactants and the products. So this would be a not